say it again. Does anyone remember another word we can use that means the same thing as rate of change? It's a game on the Chromebook with the little green ball. Slope. Thank you. Slope. Rate of change is the same thing as slope. Does it scare me that that's the only way we knew what it was? It was the little game? A little bit, but that's all right. Okay? Rate of change is just fancy talk for slope. What variable do we normally see representing slope? S? M. So slope is equal to M. Like we said, it's the same thing as my rate of change Another way that we could represent this is with the fraction rise over run. Same thing. We could also say delta y over delta x, delta being the Greek letter D, looks like a little triangle. And that just represents the change in y divided by the change in x. Also the same thing. And we can also add in the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Does that formula look familiar to anyone?
Yes. Yeah.
Good. Good. I hate that formula as well, but it's okay.
Oh.
Because it's annoying.
I love this one.
Oh, all right. My bad. Didn't mean to hurt your feelings.
Very hard.
Now we're going to use these different. There's the reason why there's so many different ways of saying slope or rate of change is because we're going to use a different one of these depending on what type of problem we're given. Okay. I know that I'm going to be thinking in terms of rate of change when I have a specific context. Typically, we see this with word problems where my answer is going to require me to have units on it. 60 miles per hour, $30 per session, right? My number that represents the unit rate or the slope, the rate of change, is going to have some units on it. Rise over run, I know I'm going to use when I have a graph. If I want to find the slope on a graph, I've got to pick 2 points, count the rise, count the run, put them in a fraction. Anyone know when I use delta y over delta x? Ben?
When you have coordinates.
Very close. That's when we're going to use the slope formula when I have 2 points. Right? Because I have 1 point with an x and y and a second point with an x and y. I'm going to use the change in y over the change in x when I have a table. Right? When I have a table of x values and y values and I want to find the slope, I do my little arrows from point to point. You guys remember that?
Yeah.
We're like, oh, +2 over +3. That's how I find my slope that way. That's what delta y over delta x means. So we're going to look at a couple of these. Now, rate of change can kind of be intermingled with all these because I could have a graph with a specific context. I could have a table with a specific context. I could have 2 points with a context, but not really. So sometimes these are the big three we're going to talk about. Let's call them A, B, and C. Starting out, of course, with A. Let's take a look at a little graph, shall we?
No.
You're going to get a little square. It's got a graph on it. All I need you to do is glue the little square in, just like that. All right? You are welcome.
basically saying you should consider code. No, I'm kidding. I didn't know. I don't know which one are you saying?
It's very nice. My dog has a toy that looks just like that.
Pissing me off. He's very good dog.
All right, that should be enough time to get that glued in. It's a 3" by 3" square. So, I've got a graph here. Just to review, give me a thumbs up if this is a continuous function. Give me a thumbs down if this is a discrete function. Let's see what you remember from the last test. Continuous, discrete. Continuous. How can we tell this is continuous just by looking at it? Vivian?
Because it has an arrow.
Because it has an arrow? Yes. Precious? Because it has a line. We're getting there. Oscar?
Because the line goes through all the dots.
Yeah, all three of those are exactly right. There's an arrow on the end. It's all connected by one line. Does this line pass the vertical line test? Yes or no?
Yeah.
Let me take a vertical line. Is there any point where I've got 2 points directly on top of each other? No. So this is a function. It's a continuous function. Let's find the slope. Now, obviously, the slope is going to be different in different segments of this graph. What does the x-axis here represent?
Number of weeks.
Number of weeks. What does the y-axis represent?
Total amount saved in dollars.
Total amount saved in dollars. So this function is representative of my savings over time. Does it look like my savings is going up at a constant rate? No. If we were going to interpret, you guys remember this with the plane problem on the test? If we were going to interpret what's happening here, it looks like as time is going on, I'm adding a little bit to my savings here, maybe a little less this month. Ooh, there's a big add that month. I don't add anything right there. And then what happens?
You spend a lot.
Spend a big chunk of money, but then I save a little bit more there at the end, right? So, if I'm going to find the slope, I have to be specific of in what period of time I'm finding the slope. So we're going to find the rate of change, which is the same as slope. Find the rate of change. Between weeks 2 and 3. All right. So between weeks 2 and 3, that's this little section of the graph right here, represented by this little purple line. How many dollars is each box on the y-axis worth? $50. So at the beginning of week 2, how much money is in my savings account? Who could tell me? Jimmy, you got it? At the beginning of week 2, how much do I got? Yeah, Jimmy? Absolutely right. $350. Beginning of week 2, look up, look over, I got $350. How much do I end with? $500. So within that week, I went from $350 up to $500, right? So because I have a graph, which of these am I going to use? Rise over run. So M is equal to rise over run. I'm starting at week 2, ending at week 3. I clearly see that I'm rising 3 boxes, which is $150. And I'm running 2 boxes over. How many weeks does that represent? 1. So my rise over run is going to be 150 over what? 1. What is 150 over 1? 150 what? Dollars. When I have a context to my question, I need to have a context on my answer. So between weeks 2 and 3, my rate of change, $150. That means my bank account changed at a rate of plus 150. All that means is I added $150, right? What if I wanted to find the rate of change between weeks 4 and 5? Between weeks 4 and 5, this little section of the graph. I start right here on the left. I got to do rise over run. What direction am I rising here, though? I'm rising down. How many dollars down did I rise? $400. How many weeks am I running over? 1. Am I going too fast? Okay. What's my numerator going to be, my rise? 400? Negative 400. I rose down. What's my run? What's my denominator? Just 1. What's negative 400 over 1? Negative 400 what? Dollars. I don't know if the negative's supposed to go before the dollar sign or after.
I don't think it matters.
I don't think it does either. I'll know what you mean either way, so I really don't care. So my rate of change between weeks 4 and 5, my bank account changed at a rate of minus $400. Just like we interpreted at the beginning, that means I'm not saving money during that week. In fact, I'm spending money. All right? Does that all make sense?
Yes, sir.
Perfect. Let's look at B. For B, I'm going to have you make a table. Nice looking tables. Some perfectionists in here, which I like. I'm also that way sometimes. Am I going to use rise over run with this guy? No. What method am I going to use instead? Delta y over delta x. So m is equal to the change in y divided by the change in x. If I want to figure out what my change in y and x are, what do I have to draw on the outside of my little table here? Little arrows. You guys see that okay in the back? On the x side of things in lime green, how would I get from 0 to 2? What's that a change of? Alex?
+2.
Plus 2. You guys agree with that?
Yes.
Okay. What about on my orange side? How would I get from 6 to 12?
Plus 6.
Jimmy, what am I adding? Plus 6. That's right, sir. Plus 6. Now, I want to make sure that this is constant, so I'm going to go one more. How do I get from 2 to 4?
+2.
Still plus 2. How do I get from 12 to 18? Still plus 6. We got a constant rate of change here?
Yes.
Absolutely. So, what's going to be on top of my fraction? 6.
Over 2.
And what's going to be on the bottom? 2. What is 6 divided by 2? 3. 3 what? Just 3. That's right, Janelle. Does this problem have a specific context attached to it?
No.
No, it's just random numbers in a random table. In that case, I don't need units on my answer because there's no units for me to write.
It's just 3.
Just 3. That's right.
What if it's a fraction?
It can totally be a fraction. My slope can be positive, it could be negative, it could be a fraction, it could be a whole number, it could be 0, it could even be undefined, like we've talked about. Have we talked about that? Yes, we did. Okay. Getting all mixed up and confused. Anybody still writing B? Perfect. Let's take a look at C. The natural successor to B. C. What happened to it? Did you not hear it? You don't hear
Oh, it's Halloween lo-fi. I thought it was, that exists. Do they have like Christmas lo-fi too? What? I thought it was just lo-fi.
it? See, she's a zombie.
That's so
The cat's also a zombie.
weird Halloween music.
So, C is the slope formula. This is where people have the most trouble. Now, maybe you are not most people. That's great. But most people typically have trouble. But it's really quite simple. Let's talk about it. Let's say I've got the point 2 comma negative 6. And I've got the point. It doesn't really matter, right? Negative 1 comma 4. Yeah, it doesn't matter. Oh, no, you're good. What's up?
What's your favorite teacher?
Okay.
That's your guys' favorite teacher?
All right. I got 2 points. 2, negative 6, negative 1, 4. Can I do rise over run here? Can I do delta y over delta x here? Technically I could, but we're not going to do that. We're going to do the slope formula. Slope formula says m is equal to, let's get some colors going here. 1, 2, 3, 4. M is equal to y2 minus y1 over x2 minus x1.
Why would it be the second number first and then the first?
Well, it doesn't really matter.
It
Like, why is it always x2 instead of like x1 minus x2? But they would be.
if you did y1 minus y2, you'd also have to do x1 minus x2. If you switched both the top and the bottom, you would get the same answer. Because who's to say this point is point 1 and this one is point 2? If I wrote them backwards, I would still be able to use the same formula. Does that make sense? We could try it both ways if you want. Okay. So, let's go through this quickly so that we can try it both ways. We can see some Cool stuff. Up here, I got my first point and I got my second point, right? Again, it's arbitrary which point is first and which is second. I just came up with these numbers off the top of my head. They're not even the numbers I have from last year. So we'll see if this one works out. What can I call 2? I got 4 little options here. What can I call 2?
X1.
X1, which means -6 must be
Y1.
Y1. My 1's got to stick together, right? What X sub 1 tells me, it's my first point's X value with my first point's Y value. Does that make sense? So -1 comma 4 is my second point. What can I call -1? X2, which means I'll call positive 4 Y2. Right? It's the first X with my first Y and the second X with my second Y. So let's go ahead and plug these in. M is equal to, what am I going to plug in for Y2?
4.
4. What am I going to plug in for Y1?
-6.
-6. What am I going to plug in for X2? -1. What am I going to plug in for X1? 2. It's not going to be a pretty answer, but that's all right. We have to be very careful. This is where people make the mistake. My subtraction signs, you'll hopefully notice I wrote them in before I even started plugging in numbers. Because when we have this double negative here, this is where a lot of people got a question wrong on the test, if you remember. You ended up with -20 instead of -6. You guys, some of you know what I'm talking about. Because we forgot that there's 2 negatives. When I have 2 negatives that are just about to touch each other, what are they going to turn into? A positive. So I'm going to turn this guy into one big positive. Now the top says 4 plus 6. What is 4 plus 6? 10. And across the bottom, what's -1 minus 2? -3. Can I simplify it? -10 over 3? No, but what should I do to make this look a little bit nicer? Yeah,
Put the negative sign on the outside.
that's right. Put the negative sign either outside my fraction or up on the top. We don't want it hanging out in the bottom. There's my rate of change, -10 over 3. Again, I don't want to see decimal slopes. Decimal slopes are no bueno. I want to see fraction slopes. Because again, a slope is a ratio of 2 things, the change in y and the change in x. If I squish those down into 1 decimal, I don't know what my rise is, I don't know what my run is, just makes it more messy. Now I had a good question. Why isn't it y1 minus y2? Well, let's do some trial and error here. Let's pretend the slope formula is instead y1 minus y2 over x1 minus x2. We're going to keep our, assignments up top the same, and we'll see what happens. Let's see how messy this gets. Do you guys see the difference between what I did here? I swapped the place of y2 with y1 and the spot of x2 with x1. Everyone cool on that? Okay. What am I going to plug in for y1? Actually, I just almost stepped on my own thing here. I'm going to write my minus signs first so I don't forget about them. Now, what am I going to plug in for y1? -6. What am I going to plug in for y2? Positive 4. Some of you see where this is going. What am I going to plug in for x1 down here? What? Positive 2. And what about x2? -1. So these look, on first glance, very different. All my orders are switched around. My minuses are all kind of going different ways. But let's simplify. Across the top, what is -6 minus 4? -10. What happens with these 2 minus signs that are just close enough to touch? They turn into a plus. What is 2 plus 1? 3. Same thing.
Wait, but you have to
Oh,
put
I
the
see.
negative sign outside the equation.
Or in the top. It needs to be anywhere but in the denominator. It could be out in front like this, or it could be attached to the top. Both are acceptable. Keeping it in the bottom like this is no good. Okay? That's how I feel about keeping a negative sign in the bottom. This is me.
So, oh dear. Oh no.
Okay?
Oh wait. You're not bold.
That's me. It's supposed to be a hat. It doesn't look like a hat. Now it looks like a bowl cut. But that's okay. So you guys see how the order is arbitrary. And what arbitrary means is that it doesn't matter. Now, I can't have y2 minus y1 over x1 minus x2. I can't have the 1s and 2s, not lining up. But I would just stick with this first way. But great question, Aisha. You see how it doesn't really matter? Yeah. Great.